Good day everyone, my name is Villarreal Angel May and today I will discuss all about alternative energy sources. But before that, let me read to you the learning outcomes. At the end of the lesson, the student should be able to define energy crisis and why it exists, define alternative energy sources and their reasons for existence, and identify the commonly known alternative energy sources. Why is there a need for alternative energy sources in the first place? Well, that is because of energy crisis. The term energy crisis refers to a period of substantial or prolonged shortage in the supply of energy resources, leading to difficulties in meeting energy demands. So what is renewable energy sources? Alternative energy sources, also known as renewable energy sources or clean energy sources, refers to form of energy that are derived from natural resources that can be replenished or are virtually inexhaustible. Unlike traditional fossil fuels such as coal, oil, and natural gas, alternative energy sources are considered more environmental friendly as they produce fewer greenhouse gases. Here are examples of renewable energy sources. Hydroelectric energy is a form of renewable energy that harnesses the power of flowing or falling water to generate electricity. It is produced by converting the potential energy of water stored at a higher elevation into kinetic energy, which is then used to drive turbines connected to generators. Let me show you a diagram. Let me show you a video to better understand how hydroelectric power energy is generated.
Hydropower, or hydroelectricity, refers to the conversion of energy from flowing water into electricity. It is considered a renewable energy source because the water cycle is constantly renewed by the sun. One of the first uses of hydro energy was for mechanical milling, such as grinding grains. But today, modern hydro plants produce electricity using turbines and generators. The mechanical energy created by moving water spins rotors on a turbine. This turbine is connected to an electromagnetic generator which produces electricity when the turbine spins. There are two main types of hydroelectricity production: dams and run-of-river. Hydro dams utilize the potential energy from dammed water to produce electricity. A dam is a large barrier constructed to raise the level of water and control its flow. The elevation created by the dam creates gravitational force for turning the turbine when water is released. Some dams also contain an additional reservoir at their base where water is stored to be pumped to the higher reservoir for release when electricity is in demand. This is referred to as pumped storage hydro. The second form of hydroelectricity production is run-of-river hydro. Run-of-river still uses turbines and generators, but relies on natural water flow rates of rivers, diverting just a portion of the water through turbines. Because run-of-river hydro is subject to natural water variability, it is more intermittent than dammed hydro. There are various.
Here are the advantages of hydroelectric power generation. The source of hydroelectric power generation, example water, is free of cost. Dams can provide virtually continuous electricity generation. The water used for power generation can be put to use again. There is no chemical process involved in the power production process. Therefore, the power generated is clean and does not harm the environment. Solar energy refers to the radiant light and heat emitted by the sun, which is harnessed and converted into usable energy through various technologies. It is a renewable and abundant source of energy that can be used to generate electricity, heat water, power vehicles, and provide lighting.
The Earth intercepts a lot of solar power, 173,000 terawatts. That's 10,000 times more power than the planet's population uses. So is it possible that one day the world could be completely reliant on solar energy? To answer that question, we first need to examine how solar panels convert solar energy to electrical energy. Solar panels are made up of smaller units called solar cells. The most common solar cells are made from silicon, a semiconductor that is the second most abundant element on Earth. In a solar cell, crystalline silicon is sandwiched between conductive layers. Each silicon atom is connected to its neighbors by 4 strong bonds, which keep the electrons in place so no current can flow. Here's the key. A silicon solar cell uses two different layers of silicon. An N-type silicon has extra electrons, and P-type silicon has extra spaces for electrons, called holes. Where the two types of silicon meet, electrons can wander across the p-n junction, leaving a positive charge on one side and creating negative charge on the other. You can think of light as the flow of tiny particles called photons shooting out from the sun. When one of these photons strikes the silicon cell with enough energy, it can knock an electron from its bond, leaving a hole. The negatively charged electron and location of the positively charged hole are now free to move around. But because of the electric field at the p-n junction, they'll only go one way. The electron is drawn to the N side, while the hole is drawn to the P side. The mobile electrons are collected by thin metal fingers at the top of the cell. From there, they flow through an external circuit, doing electrical work like powering a light bulb, before returning through the conductive aluminum sheet on the back. Each silicon cell only puts out half a volt, but you can string them together in modules to get more power. 12 photovoltaic cells are enough to charge a cell phone, while it takes many modules to power an entire house. Electrons are the only moving parts in a solar cell, and they all go back where they came from. There's nothing to get worn out or used up, so solar cells can last for decades.
Here are some advantages of solar energy. Now let's talk about wind energy. Wind energy is a form of renewable energy that harnesses the power of the wind to generate electricity. It is a clean and sustainable energy source that has been used for centuries, but it has gained significant attention and development in recent years due to the need to reduce greenhouse gas emission and combat climate change. Here's a diagram to show how wind turbine works.
Every 24 hours, wind generates enough kinetic energy to produce roughly 35 times more electricity than humanity uses each day. And unlike coal or oil, this resource is totally renewed each day. So how can we harness this incredible amount of energy? And is it possible to create a world powered entirely by wind? The basic principle of wind energy is simple. A series of sails or blades mounted around a rotor catch the wind and translate its kinetic energy into rotational energy. Traditional windmills use that rotational energy to grind wheat or pump water. But in modern wind turbines, it turns a generator that creates electricity. This conversion from wind to rotational energy to electricity has defined wind turbines since their invention in the late 19th century. And there are three primary factors that determine just how much energy they can produce: the size and orientation of the blades aerodynamic design, and the amount of wind turning the rotor. First up, blade orientation. Wind turbines can be designed with their rotor on a vertical axis or a horizontal axis. Vertical blades can pick up wind coming from any direction, but with much less efficiency than horizontal axis rotors. Horizontal designs allow blades to capture the wind's full force by tracking the wind's direction and turning to face it. This turning process is called yawing, and older windmills achieved it through manual monitoring. Today, wind sensors and computer systems automatically adjust the blades with expert precision to capture as much energy as possible. Outside rotor orientation, the blades themselves need to be shaped to maximize efficiency. While early designs used flat blades, modern blades are curved like airplane wings. Wind travels faster over the curved surface, creating a low-pressure pocket above the blade that forces it upwards. Since the amount of lift depends on the angle at which the wind is moving relative to the blade, modern blades also incorporate a twist, optimizing how much of the blade can cut into the wind. Made of fiberglass and resin layers, these blades are strong enough to operate through rain, lightning, and blistering sunlight for over 20 years. Even with aerodynamic blades and a horizontal rotor, A wind turbine can only capture wind if it's in a windy environment. Wind speeds typically increase the higher into the atmosphere you travel. So today, most turbines are well over 100 meters tall, with equally large rotor diameters. A turbine of this height and size can capture a huge amount of wind, generating enough electricity every year to power 750 American homes. A wind farm of 200 similarly sized turbines could power over 150,000 American homes, or twice as many European homes, for an entire year. Offshore wind farms contain an even greater number of even larger turbines. In 2019, the largest wind turbine ever built began operating off the coast of the Netherlands. With a rotor diameter of 220 meters, just one of these turbines can meet the annual power needs of 16,000 European households.
Advantages of wind energy: renewable and sustainable, clean and environmental friendly, and low operating cost. Now the biomass energy. It refers to the energy derived from organic matter such as plants, agricultural residues, forestry waste, and dedicated energy crops. It is a renewable energy source that can be used for various purposes, including electricity generation, heating, and transportation. There are several ways to convert biomass into energy. Let me show you a diagram. Here's a video to further understand biomass gasification.
Energy 101. Biomass, the original renewable energy. It's been part of our lives since our ancestors learned to control fire. In fact, it's made possible by the sun, whose energy is absorbed by trees and plants through photosynthesis, and then released when organic matter is burned or decomposes. First, there's plant waste. Wood scraps, sawdust, and crop waste can be collected from farms or manufacturers. The waste is burned to heat water. The hot water creates steam. The pressure of the steam spins a turbine. The turbine powers a generator. The generator creates electricity. Simple, really. Next up, animal waste, also known as the problem of cow poop. The solution? Waste from farm animals can be collected in a large tank called a digester, filled with bacteria that eats the waste and converts it to methane gas. The methane is captured and burned to heat water and create steam. Sound familiar? Second verse, same as the first. This same principle can also be used to capture methane, a potent greenhouse gas with 25 times the heat-trapping ability of carbon dioxide, from landfills. Once a section of the landfill is closed off, pipes are run from the waste to collect the gas, which can then be burned to make electricity or heat. Biomass may not be the prettiest form of renewable energy, and it needs to be used carefully and thoughtfully to protect ecosystems and prevent greenhouse gas emissions. But it can be a smart way to make use of waste. Power to the poop!
Biomass advantages. Biomass is always and widely available as a renewable source of energy. It is carbon neutral. It reduces the over-reliance of fossil fuels. It's less expensive than fossil fuels. Biomass production adds a revenue source for manufacturers and less garbage in landfills.